We are going to talk about the unit circle. I just want to add in an x and y axis here. Okay, that's not bad. Okay, so this is a unit circle, and a unit circle means that the radius of the circle is equal to 1. Yeah? So if I mark out these points, this is the radius, and we know that the radius is 1, which means the coordinates of that point are 1, 0. Yeah? If you move up to this point up here, again, this here is the radius, and the radius is 1, which means that point up there is going to be 0, 1. Yeah? So this one down here is 1, 0 because it's 1 on the x-axis, 0 on the y. And then this one up here on the y-axis is going to be 0, 1. Yeah, and you continue around. So this one over here on the left is minus 1, 0. And the one on the bottom is 0, minus 1. So you can write this then in terms of, we're trying to link between writing it in terms of coordinate geometry, so using coordinates, and then writing it in terms of trigonometry. Yeah? So if I just pick a random point here, I'm going to draw a line up to that. Hang on. Okay, so there's a line, and we'll call that point P, and I'm going to mark the angle theta. Okay, when you're rotating around a unit circle, you always start here and you move in this direction. So you pass through this quadrant first. So this is referred to as quadrant 1. You move into quadrant 2, then quadrant 3, and then down here into quadrant 4. As you go through those quadrants, the angle, obviously the starting angle is 0 degrees. So as you move up to this point here, 0, 1, that angle now has rotated through 90 degrees. Continue down to the next kind of key point over here on the left, that's 180 degrees. And then down to the bottom is 270 degrees. And then if you go back to the start, you've done a full circle and it's 360 degrees. And if you want to keep going, like 370, 380, then you just start heading around again. So it's a circle, obviously, so it'll keep going and going and going and going and going. So you can do things like 410 degrees, you'll just have to go around the circle once and then head around it a second time to get to something like 410 or 520 degrees, something like that. Is that all right? Now, sorry, back to the point P. So I'm just going to move this out of my way. Okay, so if we concentrate, I don't know if I can get rid of this without deleting everything. Let's try. Okay. So if I look over here at this line here, I'm going to drop a line down to make a triangle. Yeah? Now, the coordinates in the true sense of the word, the way we always do coordinates of P is going to be X, Y. Yeah? So the X value of P, or the X coordinate of P, is going to be whatever that is. So it looks like over half, so maybe 0.6 or something. And then the Y coordinate of P is going to be over there. Yeah, because that's how we do it. When we do X, Y, we always do like move to the right, move up, or move to the left, move up, or whatever it is. You always start from the center, and then the X tells you how far you go right to left, and the Y tells you how far you go up or down. So in that triangle there, which I created using the point P, you can see where the X part of the coordinate came from and where the Y part of the coordinate came from. Essentially, X comes off the X axis, Y comes off the Y axis. Yeah? So, I'm going to do SOHCAHTOA. Yeah? So, I'm going to start, just to be awkward, I'm going to start with cos. So we know that the cos of the angle is adjacent over hypotenuse. And if I apply that to the little circle I've just drawn, okay? So, my right angle is down here, meaning this highlighted pink line is the hypotenuse. My angle is over here, meaning y is my opposite, and that makes x my adjacent. Yeah? We did all this on Monday. So if the cos of theta is equal to adjacent over hypotenuse, you can see from the picture now that the adjacent is x and the hypotenuse. So hopefully you can see that the hypotenuse goes from the center of the circle to the circumference of the circle, meaning the hypotenuse is a radius, and this is a unit circle, which means the radius is 1. So it's over 1. So from there, therefore, cos theta equals x. Yeah? And if we do sine, so this part, I get the sine of theta is O for opposite over h for hypotenuse. The O for opposite is y, and the hypotenuse again is 1. So therefore, sine theta equals y. Yeah? So I can now write P kind of in a new form. I can write it in the old form, coordinates, x coordinate, y coordinate, or I have now learned how to write it in terms of trigonometric coordinates, which means I can write it as cos theta sine theta. And I always remember, in case you don't want to go through the trigonometry, to remember which one comes first. Cos is first because C alphabetically is first before S. So it's always cos sine because, yeah, that would be alphabetical order. So that's a handy way to remember which one is first if you don't want to go through the trigonometry. So then over here at the side, I just want to have a little conversation about tan. Okay? So we know the formula that the tan of theta is opposite over adjacent. Yeah? And there is a formula on page 13 of the Formula and Tables book that says the tan of theta is sine theta over cos theta. Right? Now, I'm going to do a little bit of substitution. Okay? So in for sine theta here, yeah, I'm going to sub in this. And then I'll just change colour. In for cos theta, I'm going to sub in that, right? So I get tan theta equals, instead of sine, I'm going to put opposite over hypotenuse. And instead of cos, I'm going to put adjacent over hypotenuse. Yeah? So this here, this yoke I have here now, is a fraction divided by a fraction, which means it's KFC. So I have tan theta equals opposites over hypotenuse, leave it alone. So keep the first. Flip the second becomes hypotenuse over adjacent. And then change the divide into a multiply. And then what happens is the hypotenuses cancel, one above, one below. So I get tan theta equals opposite over adjacent, which is true. Yeah? Now, you don't need to do that, but I'm just proving that the formula, this yoke here, that's on page 13 of the Formula and Tables book, it doesn't come out of thin air. It has a purpose, and it has you can prove it. You can prove it to be true. Okay, so it's not just a formula that we accept. It is proven to be true. Yeah, that tan is sine over cos. Right? So, with that in mind, the very last thing I want to do, I'm going to need a different colour though. Purple maybe. So we're going to talk about the different quadrants. Okay, so I'm going to make a mess of this, but I will get rid of it all. So see this whole quadrant here, right? That whole top right quadrant. If you put a coordinate into that quadrant, you're working on this bit of the x-axis, which is the positive side of the x-axis, and then this bit of the y-axis, which is also the positive side of the y-axis. So anything that goes into that quadrant is always going to have two positive coordinates. So it's going to be like, I don't know, 3, 3, or 2, 6, or 1, 8, or 7, 3. It's always going to be positive, which will take you to the right of the origin, and then positive, which will take you up. And that's what will bring you into that first quadrant. Yeah? So, if the coordinates are always going to be plus plus, so the x coordinate is plus and the y coordinate is plus, that means the cosine is going to be positive, as in if the x is positive, the cosine is positive. And if the y is positive, the sine is positive. So then, because we know that tan is sine over cos, and both of those are positive, then we know, because plus divided by a plus is just a plus, we know that tan is also positive in that quadrant, right? So I'm going to write this quite small. In this quadrant, oh no, the x coordinate is positive, so cos is positive. The y coordinate is positive, so sine is positive. And if you divide a plus by a plus, the tan is also going to be positive, right? So we call this quadrant, this will make a bit more sense later. Oh, I put an A in that quadrant, and that A means all positive. Okay, so let's move into the, where was I? Here? Into the second quadrant, right? So we're moving over to the left here. Now, let's look at the axis that we're dealing with. So the x bit in this quadrant is that bit there. Now that is the negative side of the x-axis, which means in this quadrant, the x value is negative. If the x value is negative, that means the cos is negative. Yeah? In this, we look at the y, that is the top of the y-axis, which is the positive part. So the y is positive in this quadrant. And if the y is positive, that means the sine is positive. And from there we can get the tan. So tan is sine over cos. That is plus over minus, and a plus divided by a minus is minus. So in this quadrant, because to get a point to go into that quadrant, it would have to be something like -4, 8. You want to go left and up. you need your x coordinate to be negative and your y coordinate to be positive. So that means cos is negative, sine is positive. Tan divides sine by cos, so it divides plus by a minus, leaving you with a minus. So in that quadrant, the only thing that's positive is sine. So we put an S in that quadrant, and that S represents the fact that sine is the only positive trigonometric ratio in that quadrant. Okay, we keep going. So moving down into quadrant 3. So if we're down here, or if we're trying to pick a point that's going to get us down here, we'd need to go minus 5, and then we want to go down, so like minus 8. Yeah? So to get down here, both would have to be negative, wouldn't they? We need a minus x value to get us to go left, and we need a minus y value to get us to go down. So our x would be negative and our y would be negative down here. Yeah? That means our cos is negative and our sine is negative. And what does that mean for tan? So tan is sine over cos, which is minus over minus. So the tan is actually going to be positive because 2 minuses make a plus. So this quadrant becomes the t quadrant because the t represents that the only positive trigonometric ratio here is tan. And then the last one, so again, think about your geometry. How would I get a point down here? I would have to go right and then down, which means I would need a positive x value. So like, I don't know, 2. 2 would bring me to the right. And then like something like minus 11 would bring me down. Yeah? So over here, I want the x to be positive and I want the y to be negative, which means the cos is positive and the sine is negative. And that means the tan is sine over cos, which is minus over plus. Different signs give you a minus. So then the only positive one in this quadrant is going to be cos. So you get what's called the cast circle. C-A-S-T. And those letters represent what is positive in those regions. So in this quadrant here, all sine, cos and tan are positive. In this region here, sine is positive. In this region here, only tan is positive. And in this region here, only cos is positive. Okay? So that's the cast circle. It is just a series of information, and most of it being information you already know that I'm just manipulating and putting into this circle. We are then going to use this unit circle and all of this knowledge to solve trigonometric equations.